chemical equations and solubility rules. So when determining the states of matter, it's important to look at the solubility rules to determine if a solid is formed. When writing a chemical equation, you always want to do three things. Write the products, balance, write states of matter. So let's look at this problem as an example. For the reaction between aqueous chromium-3 nitrate and aqueous lithium phosphate, write the molecular equation, the states of matter, and balance the equation. Write the net ionic equation. Okay, so chromium-3 nitrate. So chromium is a transition metal. That 3 means that I have Cr3+. Nitrate is a polyatomic ion, NO3-. So when they come together, they're going to form CrNO3, parentheses, because nitrate is NO3, that's how it exists, 3, because the 3+ goes to the nitrate. Now it's told, or it's telling us that's aqueous. So one reactant's done. Then lithium, group 1, +1, phosphate, which is PO4, 3-. So the 3- is going to go to lithium. So we have Li3, parentheses, or no parentheses, PO4, and that 1 goes to the phosphate. This is also aqueous. Now we have to write our products. So the chromium is the positive, which is going to go to the phosphate. And the lithium, this positive, is going to go to the nitrate. Now, their original charges will form the new compound. So lithium is a +1, and nitrate is a -1. That's how it exists. So they will form lithium nitrate. And then we look, all right, what solubility they have? Well, soluble ionic compounds. Nitrate is always soluble except with nothing. There's no exception, so this is aqueous. Now, we have chromium with phosphate. Chromium is +3, and phosphate is -3. So those 3 cancel out, and we get chromium phosphate. Now, phosphate is under the insoluble compounds. Phosphate is always not insoluble except with NH4 and alkali metals. So it's always a solid except for if it is with NH4 or any of the group 1 metal cations. Chromium is a transition metal, so it does not follow under the exceptions, and therefore this is a solid. Now we're not finished yet because we have to make sure we balance our equation. Now I have 3 nitrates here, so that means I need 3 here, which gives me 3 lithiums, and then I am completely balanced. Now, the difference with this question is it says, write the molecular equation, which we done, the states of matter, balance, and write the net ionic equation. So the net ionic equation just shows what's actually happening. So in this equation, this is our main product. If you put 2 aqueous solutions together in a beaker, you have, for example, lithium phosphate, and then you pour in chromium nitrate. What's going to happen is a solid forms here at the bottom, which is chromium phosphate. So that's the main product. Now, a net ionic equation shows us exactly which ions had to do with forming that equation. And the way to do that is to first write an ionic equation. So you split everything up into ions that's aqueous. So we have chromium, which is a 3+. And nitrate, which is a -1. That's how that came together. Then we have lithium plus and phosphate, which is a 3-. Now, lithium nitrate splits up because it's aqueous. We have 3 lithiums, and since the 3 is a coefficient, it also goes to nitrate. And now, chromium phosphate does not split up because it's the solid. It's not aqueous. Then you cancel out your spectator ion, anything that's the same on the right and the left side, to let just your net ionic equation show what actually made your product. Well, I know I have chromium here, ion, but I do not have chromium ion here. I have it as a compound. I have nitrate and nitrate, and I forgot to add my 3 nitrates here. So good check here. Because I have a 3 here, there means I need to have a 3 here. So then I have 3 nitrates, and I made the exact same mistake with lithium, 3 here as well, because that 3 right there. Then you have, so 3 nitrates, you have 3 lithiums. So then your net ionic is just everything that's left over. Chromium 3 plus phosphate makes chromium phosphate. And then you're done. So key is to write your reactants and products, the states, and then balance. When you're writing your ionic equation, make sure you write the coefficients. So I did it here, and then I just forgot here. Because there's a lithium 3, there's 3 lithiums when you're writing the ionic. Because there's a 3 on the outside of the nitrate, there's 3 nitrates. Then you cancel out whatever is the same on the right or the left, once you've determined whether you have a solid or not. Now, if everything was aqueous, you would have no reaction. But because we had a solid, we were looking for just the ions that had to do with making that solid. Now, the net ionic equation shows